Hi y'all, in this lesson video we will be looking at critical thinking about statistics. So you may have heard the phrase, there's three types of lies: lies, damn lies, and statistics. But that can be avoided. The way you keep from being taken in by bad statistics is by having a healthy skepticism, asking questions, and observing and analyzing what methods have been used in this research. So the first thing we're going to talk about is sampling bias. And mostly for the rest of this course, you will be given a data set and you're going to conduct analysis and data conclusions on this data set, assuming that this is a representative sample from that population. Because if it is not, then all the interpretations of the analysis are worthless. So let's first talk about how you know you have a representative sample. We want the sample to be representative, which means we want the sample to be similar in characteristics to the population. The important thing is that if a sample is not representative of the population, then the generalizations to that population will be invalid, and we don't want that. And the way you know you have a sampling bias is that you can't look at the sample and know it's biased. You have to look at the process of how it was sampled and see if it's likely to be biased. So when you're looking at a sampling procedure, ask yourself what elements of the population are not representative or underrepresented, and what elements are overrepresented in the sample. Here's an iconic picture of President Truman from 1948 holding up a newspaper that says, Dewey defeats Truman. The Chicago Tribune had done some phone survey and they had not gotten a representative sample of the general population and ended up making a raw conclusion, which was a mistake. So what they did was they had telephone surveys, but in the 40s telephones were not widespread, so obviously this was not representative of the general population. The first problem that we will talk about is convenient sampling. Convenient sampling is just what it sounds like. Subjects are chosen for the sample just because they are convenient. These are the worst kinds of samples to take. Here's an example. If we want to know how much money people are spending on Christmas presents, we might go to the mall the day after Thanksgiving and interview people as they pass by a certain water fountain. Well, obviously, this is problematic because think about who gets overrepresented here. People who go shopping the day after Thanksgiving, specifically at this mall. People who are underrepresented are people who don't buy Christmas presents at all, people who shop places other than the mall, people who avoid the day after Thanksgiving sales, and maybe people who shop at a different area. So the question is, of the people who are excluded, do they have different buying habits than the people who are excluded? And I think it's pretty safe to say yes, they do. So that's an example of convenience sample, which does not give a representative sample. But it's not always so obvious, which is why it's important to have a little skepticism, like I said earlier. So the next problem we address is non-response. Non-response bias happens usually with mail or telephone surveys. The people who you get data on are different than the ones who you don't get data from. Non-response is an increasing problem than it used to be because voicemail, caller ID, and people are more concerned about giving information to strangers now. Response rates in any kind of survey this way are usually low. So if you think about getting um, a call for a number from a number you don't recognize, you probably are not likely to answer the phone, or if you do, you are more likely not to answer their questions because there have been some telephone scams, and the same thing with mail surveys, since they take a lot more effort to fill out usually. So for phone surveys, you're lucky to get a 10% response rate and less than that for male surveys. Therefore, this is not a good representation to the general pop, so we want to be careful generalizing answers. This type of problem, non-response, is what was the real problem for the Dewey versus Truman story. Since, like I mentioned, it was a telephone survey in which having telephones was not as common in the 1948. So mostly rich people in the 40s had telephones. So the people who answered the survey were the rich people. And it turned out that the rich people were voting for Dewey. But in general, the general population went the other way. So that's an example of non-response bias. Now, voluntary response bias. Voluntary response relies on volunteer subjects. This is similar to non-response bias. The difference here with non-response bias, you are reaching out to someone who declines to answer, whereas with voluntary response, everyone is welcome to answer, but people had to take the initiative to answer. What I care about most out of the problems is that you recognize sampling bias when you see it, not so much to categorize it, such as this is voluntary response versus non-response bias. But an example of voluntary response bias is comment cards at a restaurant. The sample is not randomly chosen. You had to take the time and effort to fill out the comment cards. Usually people who are motivated either had an exceptionally good or an exceptionally bad experience fill these out. One thing you specifically need to think about with sampling bias is in the interpretation of the results. You have to think about how that impacts inference to the population. So for instance, in the Christmas shopping example, we had sampling bias. We have to think about the limitations this puts on our inference. So instead of making a conclusion about all Christmas shoppers, we can infer to the population of people who shop at the mall the day after Thanksgiving. So because we don't have a sample of everyone, we only have a limited population, we can only infer to the limited population. And in the restaurant example, we can't infer to all customers, only to those who would volunteer to fill out the cards, which provides very weak conclusions. Some other problems with the collections and interpretations of the data. Let's talk about faulty questions. Anytime there's a survey, there are questions, obviously. But if the questions are confusing, phrased in a way that people don't understand, terms in them that people don't know, or if they're leading questions, you will get bad data. So here's an example. Are you in favor of euthanasia to stop the suffering for terminally ill patients? There are two problems with this. Not everyone knows what the word euthanasia is, and if they don't know, they probably won't ask and just put an answer. The second problem is that the question is leading. So they're telling you basically that euthanasia stops the suffering from terminally ill patients. Are you in favor of that? So the way that question is phrased tells you how to answer. So if you rephrase it in a way that is more balanced, you're much more likely to get people's true opinion. If questions are worded in a confusing or leading way, like the example we just looked at, the results of the survey may be worthless. The next problem we look at is motivation to lie. In surveys that have a sensitive subject matter, the researcher needs to be careful how they go about getting their results. Here's an example that did happen where homeroom teachers asked students for a show of hands of who had ever tried marijuana. Well, obviously the problem with that is that you want to get students to tell the truth. With something like that, they won't tell the truth. Usually you can fix this problem asking questions anonymously, do a written survey and tell students not to sign their names. There's a whole field of study and survey research about how to reduce this problem of lying. Like for instance, the written survey might not be trustworthy either. Students would think that teachers may recognize their handwriting. So there's more, it goes more in depth of how to fix this problem. The next thing we will talk about is self-interest study. One thing you want to ask while you're reading a study is who sponsored this study. If it's a corporation or a special interest group, you want to be wary of it, not saying that they necessarily fabricate results, but they do have motivation to design and publicize studies that benefit them. Okay, so the last two things we are going to talk about are interpretation and results, not so much in sampling of design anymore. The first one is basis for comparison. Okay, so before we talk about this example, let me talk about another one that may make this example a little bit more easier to follow. So suppose we found out orchestra conductors live to be 83 years old on average. Well, it might be tempted to look at this statistic and think that really means that orchestra conductors tend to live a longer life, perhaps because of the creativity. But what we need to do is compare that group to another group, like the general population who lives into adulthood, or the general population of creative people. And if we can determine something different about being an orchestra conductor that would lead one to have a longer life, this would be our main objective. So with that in mind, here's an example that's a little bit more challenging. Uh, so suppose we found out that 68% of all teen suicides come from a broken home. And if you just look at that number, it may give you an idea that coming from a broken home is perhaps a contributing factor to teen suicides. But 69% of all teens, almost the same percentage, don't live with both parents. So what does that mean? It means that if you look at victims of teen suicides and the general population, they are the same in terms of the frequency of coming from a broken home. So that makes it sound like coming from a broken home is not a factor at all, because the teen suicide victims have the same percentage of coming from a broken home than everyone else. So just looking at that statistics alone can be misleading. The last thing we are going to talk about is correlation versus causation. And we often say correlation does not imply causation. And what that means is the fact that two things occur at the same time does not necessarily mean a cause and effect relationship. So here's an example. Suppose we found out people who take medicine for high cholesterol have higher rates of heart attacks than the general population. The conclusion that someone might draw is that the medication for high cholesterol causes heart attacks. Well, the people who take medicine for heart attacks are taking it because they have a high risk for heart attacks by virtue of their high cholesterol. So you don't know if it's the medicine that's causing heart attacks or what caused them to take the medicine in the first place. So cause and effect cannot be determined here. And go to the next video. I'll do part 2 on the next video since I'm running out of time, and I'll pick up right here.